So far, we've been introduced to position and velocity. These are two very important physical quantities that describe motion. Velocity, we remember, is defined as the change in position with respect to time. And that is, in fact, the slope of the position versus time graph. So if we take a certain period here on this graph of a few seconds, and then we look at the slope of the line. So the slope of this line is the rise over the run, which we remember from math class, and that is in fact the velocity. So we look then at the velocity versus time graph, and so far we've only discussed cases where we have constant velocity that's indicated here by this flat line. Well, what is the slope of a flat line? Again, the slope is just the rise over the run, and we can see here that there's no change in the vertical direction. So the rise over the run is equal to 0. There's no rise. It doesn't change. It's flat. So obviously, there are cases where your velocity changes. If you're sitting in your car and you're standing still at a stoplight and then you press your gas pedal, you begin to accelerate and your velocity begins to change. Your speedometer starts at 0 and then it starts to increase. So if this is your speedometer and this is 0 miles per hour, after some period of time, the speedometer will then be, say, at 50 miles per hour. So clearly this is a change in your velocity. If your velocity was initially 0, after some period of time of pressing the gas pedal, your velocity is now 50 miles an hour. So your velocity has changed. So change must mean then that the rise over the run is not 0. So let me write that over here. I'm going to introduce acceleration and describe that in the same way that we describe velocity. So acceleration is defined as the change in velocity over the change in time. Okay? So again, we started at 0 miles per hour. Our velocity changed to 50 miles per hour. And obviously that would have had to take some amount of time. That can't happen instantly. That's not possible. So that is acceleration. So acceleration is the case where we have a slope on our velocity versus time graph. So let me draw another graph over here. And in this case, we're not going to have a flat velocity line. So we'll do another velocity graph, and I'll draw a case where the acceleration is not equal to 0. Again, that's synonymous as saying that the velocity is constant if the acceleration is equal to 0. So, okay, let's draw this here. We're going to give it some slope, just like we did with the position graph. So in this case, I have a non-zero slope. I can see that there's some change in the vertical direction, so the rise over the run is not equal to 0. So in this case, the rise over the run, this symbol means is not equal to 0. So we have some sort of constant velocity. Why is it constant? Well, the slope is the same. So we know that the slope at every point on this straight line is the same. It doesn't matter if you measure the slope of this tiny piece or if you measure the slope of this whole line right here. It's exactly the same at every point on this line. In fact, the slope is going to be the same at a point right here. Even if the rise over the run is very, 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 very small, each one's very tiny, at this point, you would still have an instantaneous slope, an instantaneous acceleration. And why do I bring that up? Well, because we've been dealing with straight lines, but in many cases, your acceleration might not be a constant value. If you start from 0 and you press the gas pedal a little bit, you're going to accelerate a little bit. If you press the gas pedal harder a moment later, you're going to start to accelerate more quickly. So a velocity versus time graph, if we can have multiple accelerations over some period of time, then we're not going to have a straight line. So our velocity versus time graph could be, say, a curve. Maybe we're accelerating like slowly to begin with, but then we start to increase our acceleration. And now we have a curve. Well, the same principle applies. At any point here, the slope of this point is equal to the acceleration. It's the change in velocity over the change in time. And we can draw something called a tangent line. You may have been introduced to this in math class, but this line would only touch this curve at one point. It might look here like it's touching it at multiple points. That's just a fact that this is an imperfect graph. But a tangent line will only truly touch a curve at one point, and we can indicate that right here. All this is to say that velocity is not always going to be a perfect straight line. Position's not always going to be perfectly increasing in one direction in the real world. In this class, fortunately, we only have to deal with cases where acceleration is constant. And what does that mean? Well, if acceleration is constant, then the velocity versus time graph is going to be a straight line. It has to be, because then the slope is a constant value. So again, the slope here for this section, for this straight line, is the same as the slope over this big portion, which is the same as the slope over this whole triangle. So fortunately, we don't have to work with these tangent lines, but I just wanted to bring this up because physically in the real world, velocity is not always going to be a perfectly straight line. To figure out the slope of this line on this curve, we would actually have to use some basic calculus, but that's not something we're going to do in this class. So just to recap then, acceleration is defined as the change in velocity over the change in time. And in this class, we're going to deal with constant acceleration. We won't have to deal with the case where acceleration is changing. The acceleration at this point is different than the acceleration at this point. The tangent line becomes more steep at this point than this bottom point down here. So we won't have to deal with that. This is not something you'll have to deal with. This is just for your information that in the real world, that's how motion changes. Okay, it's not always nice straight lines. We're going to only have to deal with constant acceleration. So we're going to start exploring acceleration a little more in future videos. I just wanted to introduce it here. Again, it's the slope of the velocity versus time graph. So it's going to tell you how much velocity is changing. If you start from 0 miles per hour, for example, in a car at a stoplight, and then you press your gas pedal, well, obviously your velocity begins to change, and eventually it could go up to some value, say 50 miles per hour. So some sort of acceleration had to take place.